A ship leaves its home port and sails on a bearing of south 61 degrees, 50 minutes east. Another ship leaves the same port at the same time and sails on a bearing of north 28 degrees, 10 minutes east. If the first ship sails at 24 miles per hour and the second sails at 28 miles per hour, find the distance between the two ships after 4 hours. Okay, so the first ship and the second ship leave the same point at the same time. One is sailing south 61 degrees, 50 minutes east. So we know how to interpret a bearing direction this way as, so you first specify either north or south, so they specify the south line. And then next is the acute angle measured either east or west from that south line. And so the acute angle is 61 degrees, 50 minutes. So it's like a 61 point something degrees east. So there's its direction. The other ship leaves at the same time, north 28 degrees, 10 minutes east. So we go from the north line, then the acute angle, 28 degrees, 10 minutes, and then either west or east, and it's saying east. So it's going in this direction. And then it's saying after 4 hours, what is the length of this line, which is labeled as X? Okay, so let's first get these angle measurements as decimals. So 28 degrees, 10 minutes. How many degrees is 10 minutes? So we have 60 minutes per degree. So 1/6. So 28 and 1/6 degrees. Let's get that as a fraction. So 28 times 6 plus 1, so 169/6. Degrees. That's 28 and 1/6. Okay, now we've got 61 degrees, 50 minutes. So how many degrees is 50 minutes? That's 5/6 of a degree. So 61 and 5/6. That's 371/6. Okay, now let's see what this angle is, because we know that this angle plus this angle plus this angle is going to be 180. So we can say that, so 169/6 plus 371/6 is 90. So that means this is a right angle. And, you know, the problems that we're working, it's very convenient that we end up with a right triangle. You can imagine for problems like this, it really, you want to lean on not just trigonometry, but geometry skills. But these problems are set up to, because we're dealing with right triangles, but still good illustrations of applied trigonometry and geometry together. Okay, so now we need more information. So all we know now is we have a right triangle. That's it. So we can't, we're going to need to solve this right triangle, or at least solve for this length, but we don't have any information. We've just identified that it is a right triangle, but we have more. The problem tells us that the first ship sails at 24 miles per hour and the second at 28, but they sail for 4 hours. Okay, so the first ship, which is the southward ship, it sails at 24, so it's miles per hour for 4 hours. So 96 miles. So this length is 96. Okay. Now, well, can we get X now? Well, no, because we don't. If we had one of these angles, we could, and maybe we could potentially get one of those angles using geometry. I don't think so. So yeah, without one of these angles, we need something else, either an angle or another side length. Well, we can get this side length. So the second ship sails at a rate of 28 miles per hour for 4 hours. So it sails 112 miles. So this distance is 112. Now we can solve this right triangle. So we actually don't even need to find the angles. We can just go ahead and use the Pythagorean theorem to get x. And that's what the question's asking. I don't think it's asking about any angle. Yeah, that's it. So let's just use the Pythagorean theorem. This is the hypotenuse, x. It's across from the right angle. So we've got x squared is equal to 96 squared plus 112 squared. And the square, well, no. Okay, but then we take the square root of both sides, and that's x. So 96 squared plus 112 squared, 16 root 85. So about 147.5 miles.